here in to our class for today. Hold on, where is it? There it is. All righty. So Tuesday, we talked about our states of matter, the different phase changes that matter can go through, going from a solid to a liquid to a gas to a solid and vice versa. We went through that heating curve where as we heat up our matter over time, there's periods where it's heating up and periods where the temperature is staying the same as we're going through one of those phase changes. And so today, we are talking about chemical and physical properties and changes. Essentially, it's the different ways that we can describe matter and how we can change the type of matter that we are dealing with. All right. So we're going to be going through kind of each one of these things individually and talking about some good examples of each one to kind of make sure that you guys understand it. So we have physical properties, physical changes, chemical changes, and chemical properties. So first up is physical properties of matter. So a physical property is a characteristics of a substance that can be observed without changing its identity, meaning that this is something that we can observe just by looking at or measuring or touching or smelling an object. We're not doing any sort of chemical tests on it. We're not changing the types of chemicals that we're dealing with. We're just observing its physical properties. Again, remember from what we talked about from the first week of class when we went over the scientific method. An observation can be any one of your five senses. So looking at something, touching something, tasting something, feeling or hearing something, all of these are observations that we can make about matter. And so if we use these five senses to make an observation about some matter, we are describing a physical property of the matter. So things like color, what type of color that we see when we look at something, how big it is, how much volume that it has, the shape and the size that it makes up are physical properties. What sort of state that it is in. So is it a solid? Is it a liquid? Is it a gas? All that fun stuff about that we talked about on Tuesday. All of those are physical properties of matter as well. They're things that we can see, we can observe when we look at the matter. We can also describe physical properties as things like measurements. So what is the density of our matter? How dense is this matter? What is its mass, which is the fancy science way of saying weight? So how much does this matter weigh? How big is it? How heavy it is it? What temperature is the matter at? If we measured its temperature, what sort of temperature would that be? These are all physical properties of matter. Again, things that we can observe about the matter, either by looking at it, measuring it, listening to it, smelling it, all of that good stuff. So, like I mentioned, taking temperature, so the fact that water freezes at 0 degrees Celsius, that's its freezing point. That is a physical property of water. All right, all matter has all sorts of different freezing and melting temperatures. So the melting point of water is probably different from the melting point of metal, which is different from the melting point of plastic, but they're all physical properties of those substances. So water, when it's frozen, we can take the temperature of it and it'll be at or below 0 degrees Celsius. This piece of metal right here is hard. Like if you feel it, it's hard, it's very solid. It's probably very heavy. Most metals are fairly dense, so they're heavy if you try and go and pick them up. What else? I bet, so it looks like it's silver, right? I bet if you touched it, it would feel really smooth, kind of like the plastic on this table or my computer that I'm sitting at. All of those are things that we can observe about these pieces of metal. We can either feel them or see them or weigh them out. And so they are physical properties. This plastic over here is clear, so we can see through the plastic to the other side of the bottle, right? We can see the table through the bottle. So that's a physical property of this plastic, is that it's mostly clear. It's pretty see-through. It's also very easy to bend, right? It's very kind of squishy. If you ever had an empty plastic water bottle, you can take it and you can squish it in your hand, or you can like crunch it down between your palms. These are all physical properties of the plastic. So it's see-through, it's easy to bend, it's easy to squish. And again, physical properties don't have to just be things that you can see or measure. It can also be things that you can smell or taste. So this used to be a peach at some point in its earlier life. Now it's not looking so good, right? So this was sitting in your fridge or in your kitchen counter, and you picked it up. Before you bit it, you could probably smell it. And I don't know if you guys have ever smelled like a really gross, rotten fruit smell before, but it's like this super sweet, yucky, sticky kind of smell. Ugh, it's gross. So that's probably what this guy smells like. So that would be one physical property of this rotten fruit that would tell you, hey, something is not right here. This fruit is no bueno. Also, it probably doesn't taste good either. So even if you are blindfolded and your nose was plugged, if you took a bite out of this fruit, it would probably taste pretty nasty. So the fact that it smells bad and it tastes even worse are both physical properties of this fruit. They're things that we can describe about the fruit through our observations, through using our senses in order to pick out that information. All right, so physical properties, all about things that we can see or measure or touch or smell or taste about matter. So they're the physical descriptors. If you're going to describe what something looked like to somebody else or what it smelled like, you would be describing its physical properties. So what happens if we take our substances like this piece of metal? It used to be one big chunk, one big piece, right? But then we broke it down into these kind of 3 smaller pieces that we stacked on top of each other. They're still metal. They still have pretty much all the same properties as they started with, only now they're in small chunks instead of one big piece. Well, by breaking the metal down like that, we have caused it to go through something called a physical change. So there are a couple different types of changes that we're going to be talking about today. A physical change is when we change the form of a substance, the form of our matter, maybe what it looks like, without changing the identity of our matter. So like with that piece of metal, we took it from a big piece of metal to several smaller pieces of metal. But it was still metal. It was still the same substance. It just went from one big piece to lots of little pieces. That is a physical change, where we have the same substance, we just change a little bit of what it looks like. So most of its properties remain the same. Sure, maybe its size may have changed, its mass may have changed, but things like the density, the feel, some of its chemical properties, which we'll talk about later, those all remain the same. We still have the same substance, it's just in a little bit different form than it used to be. So melting something is a great example of a physical change, right? If you take that ice cube and you put it out on your counter and you walk away, you come back an hour later and now there's a puddle of water on your counter. The water is still the same chemical as it was before, right? Before you had ice, which is just solid water, and now you have liquid water sitting on your counter. It's both water. It's still the exact same H2O molecule that it was before. It just changed phase. It went through a phase change into something else. So it's still water. It's still the same chemical, the same substance. It's only gone through a physical change. Same with shredding up something, right? So like if I take one of the pieces of paper in my notebook here, and I tear it out of my notebook and I hold it up on camera and I shred it up into a dozen pieces, all those pieces are still paper, right? I could pick them up one by one and each piece would still be a piece of paper. They would be smaller pieces of paper than what were there earlier, but they're still all paper. So we've changed what our paper looks like, its form, but it's still paper. It's still the same material. Same thing with like grinding. So if you're gonna like sharpen a metal or like a piece of like a knife or a piece of metal or something like that, then you have like the little blade that you like rub against the metal in order to sharpen it up. Or you have like the sandpaper that's going and then you press it against there and it grinds it down. It's just removing little pieces of metal from like the edges of your knife in order to keep it sharp, but it's still the same metal. It's still the same knife. Only now you have the big piece that's still the knife and lots of little metal shavings. They're the exact same material as the knife. They've just been ground down into really small pieces. A really similar thing happens when you're dissolving substances. So like you get up early in the morning, you have your hot coffee going, you pour it into your cup, but you don't like black coffee because black coffee tastes gross. And so you pour in some sugar and then swirl it around. And it looks like the sugar disappears, right? Even if you could see all the way to the bottom of your coffee, you couldn't see or feel the sugar anymore. But when you sip the coffee, now it tastes sweeter than it did before. It actually tastes good and not terrible. The sugar is still there. It just went from being in the big sugar clump crystals that we can see into tiny little microscopic sugar crystals that we can't see anymore, but they're still the same sugar. They're still the same substance. That's why our coffee tastes sweet, even though we can't see the sugar in there anymore. It's still there and it's still making that sweet flavor come out. So anytime we change how something looks, but it's still the same material, it's still the same item, we have gone through a physical change. So other really good examples of physical changes would be like putting some pieces of wood through a wood chipper. Right, you have a big piece of wood, some sort of big log or branch going in on one side, and then it gets all ground all up and spit all out into sawdust on the other side. This is wood, and this is also wood. It's just this is wood all together in one big piece, and this is wood that's been ground up and separated out into a couple million little pieces. But it's still the same material, right? It's still the same matter. We've just physically changed how it looks. We've taken it from one big piece into lots of tiny pieces. Another good physical change would be vaporizing or boiling a liquid. So sort of like how I talked about melting earlier, an ice cube turning to ice water is still the same water. It's just gone from a solid to a liquid. Same thing with boiling water on the stove. So you put the water in your pot, you're going to make some pasta, you put it on the stove, you crank up the heat, you have to wait for a little while because water takes a while to heat up, but eventually you start seeing the bubbles come up and all of this steam, all this water vapor is coming up off the top of your pot, right? This is water that's in gas form. And here is water that's in liquid form. It's the exact same matter. It's the exact same chemical. It's just changed phase from liquid to gas. So we've changed the form of our water, but it's still water. This is a whole bunch of liquid H2O molecules, and this is a whole bunch of gas H2O molecules. But they're still the same chemical. They're still the same matter. So it's only gone through a physical change. We've changed how it looks, but we have not changed what it is. All right, and then finally, like I was saying earlier, when you dissolve something, like I mentioned the sugar and the coffee, or I don't know if anybody else's parents ever did this, but when I was younger, whenever we had like a sore throat, like if I had a sore throat and it wasn't going away after a couple days, my mom would make me or my brother or sister gargle salt water because that was supposed to help like heal your sore throat for some reason. And so she would heat up some, like warm up some water, put a whole bunch of salt in there, stir it around, and the salt would dissolve. And then I had to put it in my mouth. It tasted awful. It was like swallowing the ocean, and you had to like gargle it around like mouthwash for a couple minutes and then spit it back out. It was not a pleasant experience. I did not enjoy doing it. But the reason the water tasted so salty is because all of the salt crystals that she poured in dissolved in the water. So the salt was still there. The salt chemical was still there. It was making the water all salty and gross tasting. But these crystals were not there anymore. These crystals are large pieces of salt, large chunks of salt that are all together. And then you pour it into the water and they all kind of dissolve apart. There's still the salt chemicals in there. They're still present, but they've gone from being together in big chunks to separated out into tiny, minuscule salt crystals that are invisible to us. So it's still salt. It's just gone from big chunk to tiny particle. It's gone through a physical change. The size of the salt particle has changed, but the fact that it is salt has not changed. It's just gone from salt that's in a spoon to salt that's dissolved in liquid. So, physical changes, all about you have the same substance at the end that you started with, it just looks, a little bit different. Instead of being a nice big piece of wood, it's a whole bunch of tiny pieces of wood. Instead of being lots and lots of big salt crystals, it's lots and lots and lots of invisible salt crystals. It's the same material at the start as at the end. It just looks different now. It's gone through some sort of change of its form. And now it is in maybe more pieces, or it's in a different state, or it's been ground down and sharpened, but it's still the same material. We've just physically changed it to be a different size or a different shape, something like that. All right. Does anybody have any questions so far about physical properties or physical changes? All righty. Doesn't sound like it. So we'll move on to the next set of changes. So with our physical changes, remember, we start and end with the same substance. We change how it looks, but it's still the same thing when we start as when we finish. But what if that's not the case? What if the substances, the chemicals, the matter that we end up with is different from what we start with? What if we end up with something new, something that wasn't there before? In that case, we no longer have a physical change. We have a chemical change. Also sometimes called chemical reactions, and we'll talk in more specifics about these later on in the school year. But in a chemical change, we do change the identity of the substance. We start off with one substance or one set of matter, and we end up with something new, something different, something that was not there before. So chemical changes are all about creating new chemicals, creating new material, new substances, changing our starting material into something different that we end up with. So the properties of our material do change, right? We get new material, it's going to have new properties, different properties than our starting material. So there are all sorts of different ways that you can tell that a chemical change is going on. You could have some sort of change of color, like some sort of unexpected color shows up in your matter. You could have gas or a new solid forming. So a lot of times, a lot of chemical changes result in the formation of a gas. Like when you mix two things together and all of a sudden they start bubbling like crazy. Like if you've ever done the classic vinegar and baking soda experiment, which like the kids like on TV, you see it all the time. They do it for like the volcano science experiment. When you mix those two chemicals together, it causes them to react with each other and create a new gas that then bubbles up and creates all of this sort of liquid explosion going on. So anytime that multiple things get mixed together and all of a sudden they start bubbling or fizzing or something like that, it's a sign that you're getting some sort of new chemical going on. Also, whenever you produce light or you produce heat as a cause of this chemical reaction, that's a good sign that you're getting a new chemical as well. So like obviously you guys we don't really have them down here. But like I mentioned on that first day, I lived in Ohio for a couple years. And for me, a lifesaver in the wintertime were these little hand warmer packs. They're the packs that looked a little bit like big versions of those like silica gel packs that you get in like shoe boxes and stuff that always say like, don't eat these, not for eating. They're kind of like that, but bigger. And when you're about to go outside and it's really cold, you would take them, you'd crinkle them up, and then stick them inside of your glove. When you crinkle up the packets, it brings the two chemicals that are inside together and causes them to mix. And when they do, they start to give off heat. And you use that heat to help keep your fingers or your toes nice and toasty when it's like 17 degrees outside. So the reason that they're giving off heat is that they're turning into a new chemical. They're turning into something different than what was there before. They're going through a chemical change. So obviously, other famous examples of chemical changes include things like burning. So another common way of producing heat and light is through burning something or combusting something. So whether you're burning firewood or propane or gasoline in your car, you're taking that starting material, the gasoline or the propane or the wood, And as you burn it, you turn it into something else, usually some sort of gas and some sort of byproduct. So the reason why you have a whole bunch of gas coming out the exhaust pipe of your car and not gasoline, gas as in like the stuff in the air, not gas as in like the liquid gasoline. So the reason all of that gas and stuff comes out the exhaust pipe of your car is because that's the new chemical that is produced when you burn gasoline. Same thing with when you have a fire with firewood. After you burn all the wood, you have a whole bunch of smoke that went up into the air and a whole bunch of ash that's left over in the bottom of your fire pit. Those are both new chemicals, different chemicals than the wood that you started with. So while it was burning, it was going through this chemical change. It was being changed into a new set of substances. Same thing with rusting. So I think I actually have a picture of it on the next page. Yeah. So burning wood is producing lots of heat and light, and then some of it is going up into the atmosphere as smoke. Some of it is left over as ash. But smoke and ash are chemically different from the wood that they started with. Same thing with rusting. So rust occurs when you have iron sit out and mix with the oxygen and the air. If that happens over a long period of time, it'll form this new brownish, crappy material called iron oxide, which we normally call rust. So the properties of iron oxide are different from iron or oxygen, right? Iron, the metal, is smooth, it's shiny, it doesn't break very easily, whereas rust is brown, it's bumpy, it's super flaky, right? It'll kind of flake off the edges of the iron. And so this rust, this iron oxide, is a new substance. It is a different chemical substance than iron or oxygen on their own. So in order to form rust, we have to go through some sort of chemical change in order to get that iron to turn to rust. Same thing like earlier when I was talking about forming a new gas can be a sign of a chemical change. That's what happens when you take like an Alka-Seltzer tablet and drop it into the water, right? So the Alka-Seltzer is this special medicine that helps with like heartburn and stuff like that. And when you drop it into a glass of water, all of this fizzing starts going on. And that's because the water and the coating on the outside of the Alka-Seltzer tablet are reacting with each other, going through a chemical change. And one of the new chemicals that is produced is gas, which then is what is formed out of all these bubbles. So it's very rapidly creating a lot of gas, a lot of new gas chemical, gas matter. And so all that gas is coming off the tablet and fizzing up to the top of your water glass here. So we're going through a chemical change. The medicine and the water are interacting with each other and creating new sets of chemicals, including this gas that is fizzing up to the top of your drinking glass. So that's what a chemical change is all about. You're starting off with one set of substances and you're ending up with something new, something different, something that was not there before. Either something is combusting or being lit on fire, or something is fizzing and producing all this new gas, or something is out in the elements and it's rusting, the metal is turning into something different. All of those are chemical changes, things that are happening and changing the matter into something different down at sort of the chemical level, at the molecular level. So physical changes, you start and end with the same thing. It just looks different. Maybe you tore it up into pieces or dissolved it in something, but it's the same chemical. Chemical changes, you start and end with different matter, different chemicals, different substances. So whatever you start off with is different than what you end up creating at the end of this change. So that's sort of the biggest difference between the physical change and the chemical change. Physical change, your starting and ending products are the same. Chemical change, your starting and ending products are different. You're creating something new, something that was not there before. All right. And then finally, the last thing that we're going to talk about today are chemical properties. So a chemical property essentially is just a characteristic of your matter that kind of describes how easily a substance will undergo a specific chemical change. So it's saying, how likely is this thing going to catch on fire, or going to react with water, or react with air? That sort of thing. So like, for example, a chemical property of my metal water bottle right here is that it's pretty flame proof, right? If I drop this metal water bottle in a fire and picked it out a couple minutes later, it's going to be super hot because it's metal, but it's probably going to be okay. It's not going to catch on fire. It's not going to start melting, anything like that. Whereas if I took a piece of paper and dropped it into a fire, paper, one of its chemical properties is that it is very flammable. Paper catches on fire pretty easily. Same thing with stuff like gasoline, obviously very flammable. That's what it's there for. Propane, very flammable. Ethanol is very flammable. If you've ever seen at like a bar or something back, in the olden days where we were allowed to go to bars, and if somebody ever ordered a flaming shot of something, the reason why the bartender can light the top of the shot glass on fire is because they put a little bit of a super high proof alcohol on there, like Bacardi 151 or Everclear, something like that. And ethanol is a substance that catches on fire very easily. It's very flammable. And so that's what allows them to create those flaming shots. Whereas things like metal or plastic or rubber, not very flammable. Pretty flame retardant, actually, meaning that it does not catch on fire very easily. So like if you took your rubber boot and just threw it into your normal campfire, it's probably going to be pretty okay. It might get a little bit of damage around the edges, but the whole thing isn't going to go up in flames. Same thing with how reactive that a chemical is when you mix it with certain other things. So like the Alka-Seltzer tablet is very reactive if you mix it with water. Same thing with there are certain metals, like sodium is a type of metal and potassium is a type of metal. If you mix pure sodium or pure potassium with water, they also will react very strongly and kind of explode in the water. They are very, very reactive chemicals. So certain chemicals will undergo reactions with other chemicals very quickly, whereas other ones, like certain gases, like the ones that go into like the big fancy neon signs, like neon or argon or xenon, stuff like that, they are very, very unreactive. They do not react very easily with other chemicals in their area. They are very safe to work with in that respect. So certain things, their chemical properties are that they're very flammable and very reactive. Other things are very not flammable and not very reactive. Other things fall kind of somewhere in the middle. But a chemical property just describes how easily or how willing will a chemical go through a specific type of chemical reaction. All right, so where a physical property kind of describes the physical characteristics of an object, the things that we can observe, A chemical property describes the chemical characteristics of the object. What types of chemicals is it likely to interact with? How likely is it to go through certain types of chemical reactions, chemical changes? That's what chemical properties are all about. All right. Does anybody have any questions about chemical changes or chemical properties, how they're different from the physical changes and properties? Any questions so far?
The color change, that's the same as burning, right? Like when it goes from a brown wood to a black coal, is that the same thing for color change?
Yep, that would be a good example of a color change. Like, yeah, how the wood goes from brown to either being like black, or if it gets really ashy, it becomes white, right? So you get kind of like that white powder on the bottom of your campfire. Those are good examples of color changes. Also, there are certain chemicals that you can mix together that will create a color change. Like, I don't know if you guys ever lived anywhere with a pool and you saw the guy doing like the little test where he picks up the pool water and then like puts in the little droplets and sees if they turn a certain color. My dad had to do that a lot. We had a pool in the backyard growing up, and so every weekend he'd be out there measuring like the salt and the pH and all that stuff. Those are good examples of color changes as well, because you have this water and you're adding this other sort of clear liquid to it, and then it turns like a kind of purpley color if you're measuring this thing, or it turns kind of a yellow color if you're measuring this thing. And those are chemical reactions that happen between the water and the stuff in it and your little droppers. Now, an example of a color change that would not really be a chemical change would be like if you're going to make some Kool-Aid, and so you got some grape flavored Kool-Aid and you poured the powder into the water and then it turned the water purple, right? That you're kind of expecting to happen because the powder is purple and then it's turning the water purple. So that kind of color change doesn't really indicate a chemical reaction or a chemical change. The ones that do are the ones where you get some sort of new color showing up that you weren't really expecting. So like you said, you get the wood that turns from brown to like black or white, and you get the pool water that turns color in the little dropper. Those are the color changes that we are talking about when we're seeing some sort of chemical change. All right, good question. Any other questions about chemical changes, chemical properties, or physical properties or changes? All right. So the homework for today and the daily assignment for tomorrow are basically asking you to look at a bunch of different situations and tell me if it's either a physical or chemical property for today's assignment and a physical or chemical change for tomorrow's assignment. So for the assignment that is due today, it has a little bit of a reminder about what are physical and chemical and properties. And then for the first part, these first couple questions right here, I want you to imagine like a piece of wood, like a big log that you might find in your backyard or in the woods, or a big stick that you see. And I want you to write down what are 3 physical properties that this piece of wood could have, And what is a chemical property that could be described about the piece of wood? So that's sort of the first part where you're coming up with physical and chemical properties on your own. And then the second part is a series of questions where for each one, I want you to tell me, is it a chemical property or is it a physical property? So things like the melting point of iron, the fact that you can stretch copper wire out into thin wire, the fact that iron will turn to rust if it's out in the air and water, the fact that ice is very brittle and it's easy to shatter a big piece of ice into lots of little pieces. So for each one of these, you can choose, does this sound like it is a chemical property of the substance, or is it a physical property of the substance? So I think there's 10 of those that you have to do for the assignment today. And then for tomorrow's assignment, so make sure again to check back in on Friday and do your Friday assignment to get your Friday attendance. It's essentially a similar group of questions, only now instead of physical and chemical properties, I want you to tell me about changes. So again, there's a little bit of a description about physical and chemical changes at the beginning. And then for each one of the situations, I want you to tell me, does this sound like a chemical change or a physical change? So hydrogen and oxygen combine together. Gasoline combusts in a car. Wood scraps are turned into sawdust in a wood chipper. You heat up a stainless steel pan on the stove. You pour acid onto some rock and it causes a whole bunch of bubbles and fizzing to appear. You pop a helium balloon. So there's 18 of these guys. And again, super straightforward for each one. I just want you to identify, is this an example of a chemical change where we are starting and ending with different sets of substances? Or is this a physical change where we're changing the form of something, but it's still the same substance at the start as it is at the end? So that is what will be posted early tomorrow morning for you guys to work on for your Friday assignment. All righty. Does anybody have any final questions about physical and chemical properties, changes, or the assignments for today and tomorrow?
No, sir.
All righty.